Welcome everyone. Guys, in these videos, I will be solving questions of past papers related to entropy topic. The questions I will be solving related to years from 2022 to 2016. The questions we are currently solving. I almost covered all the questions in these 6 years. I included summer paper, winter, and March as well. Okay, so let's get started. The first question we'll be solving is this. So take a time, have a look on the question, and then start solving it. So silver chloride, AgCl, sparingly soluble water, the equation for the enthalpy change of solution is given here. We have the equation, we have delta H solution. Standard entropies are given here as well. Calculate the standard entropy delta S. Guys, to calculate delta S, we say that delta S equal to summation of the S entropy of the products minus summation of the entropy of reactants, products minus reactants. So the products, we have two ions in the products. We have Cl minus, which is 56.5, plus we have Ag plus as well, 72.7, minus the reactant. The reactant, we have AgCl, which is 96.2. The final product will be here. Let me check. It will be 33. Okay. 96, yeah. 96.2. It will be 33. This is, guys, the delta S. Yeah, 33. The unit is joule, K minus 1, mole minus 1. We move to the next question. Explain with the aid of calculation why AgCl is insoluble in water at 25 Celsius. Sorry, you should use the answer from here. So look, guys, answer here, the delta S was positive 33. Okay, so positive 33. So we found the value of delta S. It is given for us, it is positive 33. Look, guys, whenever you see insoluble or reaction doesn't take place, something like this, the question here, the meaning of the question is, why this reaction, sorry for my bad handwriting, why is the reaction or process is not spontaneous? Why the process is not spontaneous? This is the meaning of the question. And always, guys, we have to find delta G from these equations. We need to find Gibbs free energy. So let's calculate it. So we know, guys, delta G, standard delta G equal to delta H minus T delta S, standard things here. Delta G is the thing that we are supposed to find. Delta H, guys, is given here as a solution. But there is something here you have to pay attention, and most of you make a mistake here, as what I noticed for my students. Look, guys, delta H and delta S, both they have different units. So we have to change either the kilojoule of delta H to joule or joule of delta S to kilojoule. So I'd rather convert the kilojoule here to joule. So we would say 65.5 times 1000 minus T delta S. T, guys, is given for us 25 Celsius. So it is to convert it from Celsius to Kelvin plus 273, which give us 298. All right, yeah, 298. So minus 298 times 33. The get the entropy change, the entropy. Now, guys, we end up with 55,666. The unit here in this case is joule mole minus 1. The question usually asks us to find delta G in the unit of kilojoules, so we are supposed to divide this by 1000, so we end up with 55.66, which is almost 55.7 kilojoule per mole. This is, guys, the delta G. Okay, this is delta G. So we found the value of delta G. Delta G was positive. This number, guys, any positive things mean that the process is not spontaneous. So let's move to the next question. Stop the video, have a few minutes to take a look on the question. So silicon tetrachloride can be prepared according to reaction 1. Okay, so this is reaction 1. Look like this. طيب, okay. So here we have the S entropies value. Calculate the standard entropy of chlorine Cl2, show all your working. So guys, delta S equal to S of the products minus F the S of the reactants. We know this. So if the products, S entropy of the product, it is 239. Yeah, 239 minus entropy of the reactants. The reactant side we have 18.7. This is for silicon. Okay, plus the Cl2 is unknown, so 2x because we have two of them. Okay, and delta S is already given for us. So instead of this, I would write minus 225.7. Okay, so after doing the calculations, you end up with S or X equal to 223. Okay, after doing the calculations, X supposed to be this value, 223, and the unit is given here. Explain why the entropy change for this reaction is negative. So it must be negative. Guys, why? What do you think? Why it is negative? It is negative, guys, because here we have more, or here we have gases. Okay, we have mole of gases. 2 moles of Cl2, but here we have only liquid. Guys, more number of moles of gases means more entropy. So this side will have more entropy. Okay, so how do we answer this equation? We would say in our answer, there are more moles of gas in the reactant side. And once more, sorry for my bad handwriting. Let's move to the next question. Next question. The standard enthalpy change of formation of silicon, we have delta HF. Reaction 1 is spontaneous at lower temperature. Reaction 1 is spontaneous at lower temperature. Okay, so this is reaction 1. Silicon plus 2Cl2 give us. Okay, it is spontaneous at lower temperature. But it is not spontaneous at very high temperature. At very high temperature, the reaction is not spontaneous. That means at very high temperature, delta G is positive, right? At very high temperature. It is not spontaneous at very high temperature, so it is positive. Calculate the temperature above which reaction 1 is not spontaneous. Temperature above which reaction 1 is not spontaneous. Guys, what do you mean by not spontaneous? Guys, not spontaneous mean delta G uh, is more than, just 1 second. So not spontaneous mean the delta G is larger than 0. This is what they mean by not spontaneous. Delta G, guys, as we know, it is delta H minus T delta S. So this part is not spontaneous. Sorry, as we say, delta G is not spontaneous. So delta H minus T delta S must be larger than 0 as well. Okay, so what did I do here is just I wrote this delta G is more than 0 because it's not spontaneous. And instead of writing delta G, I wrote delta H minus T delta S. Okay, so this is, guys, kind of, this is tricky question, but yeah, it can be solved this way. Delta H minus T delta S will be larger than 0 for the reaction to be not spontaneous. As we know that delta H value is given, I think it's given. Yeah, it is here, delta HF. It is minus 640. As I told you, we have to convert to Joule to deal with the value of delta S. Pay attention for the negative sign in the beginning. Minus T delta S, guys, the T is, the temperature is unknown. We needed to find the temperature. And delta S, we found it in the beginning of the question. It is given here, the delta S of the whole reaction. It is here, minus, let me show you, it's here, given here. Okay, so it is minus 225.7. That's it, we're done with this. What we are supposed to do now, just calculations. This will be minus 640,000. This minus will be multiplied by this minus, it will be plus 225.7 T. This is larger than 0. Here as well, we have larger than 0. Okay, so we add a plus this number to both sides. I hope, guys, you know the math of this. Yeah, and it's simple, I think. So here we will have T, or 225.7 T larger than 64000. Then we divide both sides by this number. So T will be larger than 2835.6. We're done with this. This is, guys, the temperature. Temperature must be larger than this. Okay, for the reaction to be not spontaneous. Not spontaneous. So as we said, not spontaneous means delta G positive, so it's supposed to be larger than 0. And instead of delta G, we just wrote this number and we are done for this equation. Let's move to the next question. So stop the video, have a look, and let's see. Entropy is measure of this order of system. We know this. Assume the entropy S for H2O is 0 K. Okay, the entropy of H2O is 0, is 0 at 0 K. Whatever. Sketch a graph on the axis to show the entropy change for water between 0 K and 300 K. 0 K and 300 K. Guys, look, let me tell you something. Water melts, or ice, let me say, ice or water the same. Ice melts at 0 Celsius, right? Or 273 Kelvin, right? I hope you know that to convert from Celsius to Kelvin, we say that Kelvin equal to C plus 273. So 0C, to find 0C, we take this number, put it here, so we get C as 0. Whatever, so you know this formula. Yeah, so we know that ice melt as 0 Celsius or 273 Kelvin. Keep this in your mind, we will need it a lot. Right, look guys, at 0, the entropy, S for H2O is 0 at 0 Kelvin. So here we have entropy on y-axis. On x-axis, we have the temperature. At 0 temperature, the S entropy is 0. Guys, when we start increasing the temperature, the entropy increases. Guys, ice look like this, the particles of ice, okay, is arranged in order manner because it is solid and a crystal lattice. When you increase the temperature, the particles start to vibrate faster, okay? That's why the disorder increases. So when I increase the temperature, the entropy increases as well, okay? So we get this line, okay? So this line keep increases constantly until a certain point, there will be huge increases in the line like this, okay? Like this, for example, there will be huge increasing in the line, but where is this point? Look, guys, we are increasing the temperature and entropy increases as well until we reach to 273. Guys, as I told you, this is the melting point of water. This is the temperature at which solid solid become liquid water. So at this point, the entropy increases tremendously. At this point, entropy increases largely. So as we see, guys, at this point, the graph move, or we see something like this in the graph, okay? In our line, we have large increasing. And then we have normal increasing, okay, and entropy. So this point at which solid water become liquid water. And this is, guys, the most important thing here. So we see normal increasing of entropy with temperature, and at this point, the entropy increases tremendously. So the question now is over. Let's move to the next question. This is very simple. Place this in each row of the table. When solid dissolve in water, delta S is negative or is positive. Guys, look, for example, we have NaCl, which is solid. We dissolve it in water, Na plus and Cl minus. We see that, guys, we get ions, moving ions. Okay, aqueous, and here we got AQ. So these moving or mobile ions, okay, so we get more disordered situations. So entropy increases. Water boiled to steam, so H2O liquid to H2O gas, guys, we have as well an increasing in entropy. So let's move to the next question. And this question, guys, stop the video, have a look. At this temperature, both the products of reaction are liquid at this temperature. Both the products type are liquid. Okay, so we got this reaction, we got this delta H of the reaction. Calculate the standard entropy change delta S of this reaction. Calculate the standard entropy change delta S of this reaction. Quite simple question, easy peasy. So delta S equal to S of products minus S of reactants. S of products, On the products, we have this one, which is 1 to 7, right? 1 to 7. Uh, yeah, just 1 second. Okay, products, yes. 1 to 7 plus 70 of the water minus the reactants. And the reactant side, we have 3H2, so H2 is 131. This guy will be multiplied by 3 plus 214. Okay, 214. So we end up with 197 minus 607. And this will give us minus 410. This is, guys, the delta S. Delta S. Okay, delta S is found. But why we have this number in negative? Why it is negative? Think about it. Right, we found delta S. Let's move to the next question. Calculate delta G for this reaction, guys. Delta G, easy peasy. Simply, it is delta H minus T delta S. Delta G equal to delta H. Delta H is given in the beginning of the reaction. It is here, minus 131. Minus 131. Minus T delta S. The temperature is 298. Delta S, we found it was minus 410. I missed something, okay? Intentionally, I did this one intentionally. Guys, don't forget to multiply this one by 1000. It's important. So we end up with minus 131,000 minus, or actually it will be plus this side, okay? 180, and we end up with 8820. The unit here is joule per mole. To convert to kilojoule as the question needs, we have to divide by 1000. So we get 8.82. Okay, we get 8.82. Yeah. Here, guys, in negative, sorry. I forget to write the negative sign. This is negative. Negative 8.82. طيب. Negative. Predict the effect of increasing the temperature on the feasibility of this reaction. Predict the effect of an increasing temperature on the feasibility of this reaction. So what will happen if we increase the temperature? Reaction now is feasible because it is negative. So if we increase the temperature, will the reaction be feasible? What do you think, guys? Look, the side here is positive. The side of entropy is positive. So if this side gets larger than this side, then the reaction will be infeasible. But how this side will be larger? If you increase the temperature, the number here, okay, increases as well. This number, I mean, the number here increases if you increase the temperature, until we reach to the point at which this side will be larger than this side. So when this side is larger, then the reaction is not feasible. So to answer this question, we would say, as we increase temperature, the feasibility of reaction decreases. Okay, decreases. The reason, guys, we know when you increase the temperature, as we say, this side gets larger and negative value, so in positive value. So delta G will be positive at the end. That's why the reaction will not be feasible.